Okay, so now we're going to talk about how to solve a linear equation. So make sure that you print out those notes that I listed for you in your module, and we'll work through those examples that I have down there. You can see them on the screen. All right, so first one says solve the linear equation 5x minus 2 equals 9x plus 2. So I gave you some steps. First step is to simplify each side. So you would want to look over here and say, is there anything I can do? Well, they're not like terms, so they don't go together. There's nothing to distribute. Same case over here. There's nothing I can do on either side. Okay, so now I'm ready for step 2. Step 2 says get all your x's on one side. It doesn't matter which side you go to, but I like to go to the left. Now to pick a term up and move it across the equal mark, you have to use the opposite sign. So I want to move those 9x's to the left. If it's a positive 9x, you come underneath it and write minus 9x and line it up under here. Okay, so those are gone now off that side, and 5x minus 9x is a negative 4x. Bring down your negative 2, and it equals 2. Okay. Now, step 3 is to get all your constants on the other side. So since I brought x's to the left, I need constants on the right. So I need to get rid of that negative 2. So again, to move it across the equal mark, you use the opposite sign. So I'm going to use a positive 2 to cancel it out. So make sure you write your equal mark every time. The people who miss these problems are the people who start dropping that equal mark. And then over here, I'm left with 2 plus 2, which is 4. Okay. Now the last step is to get the x by itself. You want to get rid of the coefficient. So to get rid of the coefficient, you divide both sides by whatever's in front of x. So I'm going to divide both sides by negative 4 so to cancel it out. So positive 4 divided by negative 4 is negative 1. Okay. So you just want to follow those steps each time. All right, let's do the second one. Second one's a little bit harder because we've got some simplifying to do. So if I look at the first one, the second one over here, the first step is to simplify. So let's distribute that 2. So I need to multiply that 2 through that parenthesis. So I would end up with 2x minus 2, and then I have that plus 3. And then over here, be careful with your distributing because you're not distributing a 3, you're distributing it a negative 3. Always grab the sign with it. So negative 3 times x is negative 3x, and negative 3 times 1 is negative 3. Now, you don't want to move things across the equal mark until you have your problem fully cleaned up. Okay, so any like terms need to go together. So I need to put those two together and those two together. Now, if they're on the same side, we just put them together using their same signs. I don't have to come underneath and use an opposite sign. They're on the same side. So negative 2 plus 3 would be positive 1. And then over here, x minus 3x would be a negative 2x. Okay, you want to get everything as simple as it'll go before you start moving around. Now I'm ready to move. I want x's on the left, so that negative 2x needs to move. So I'm going to use the opposite sign and say plus 2x to get rid of it. So I end up with 4x. To bring down my plus 1, and the only thing over here is negative 3. Alright, now I want constants on the right, so I need to move that positive 1, so I'm going to come underneath it and use the opposite sign and subtract it. So 4x equals a negative 4. And then, to get rid of the number in front of x, you divide both sides by it, so divide both sides by positive 4. So a negative 4 divided by positive 4 would be a negative 1. Alright, so let's keep going. Alright, third example. 2 minus 7x plus 5 equals 13 minus 3x. Alright, so when you have those parentheses, you're going to have to distribute. These are some of my favorites, okay? That's an understood negative 1. So if it makes you feel better to put it there, put it there. Okay, but you're going to distribute that negative 1 through this parenthesis. So let's see what we get. We would get 2. Alright, negative 1 times 7x is negative 7x. And negative 1 times 5 is a negative 5. Alright, so don't move things around until you clean it up. So I have some like terms. I can put this 2 and this negative 5 together. They're on the same side. So let's just keep our negative 7x. And what is 2 minus 5? Negative 3. Now, each side is as simple as it'll go. Now I am ready to move. So let's move our x's to the left. So I'm going to move that negative 3x. So I'm going to add it. So I'm left with a negative 4x, bring down my negative 3 equals 13. All right, and let's move our constants to the right. So let's move that -3. So I'm going to add it. So I get a -4x here and then 16 here. And then again, last step is divide both sides by the coefficient of x. So I'm dividing both sides by -4, and so positive 16 divided by -4 would be -4. Okay. All right, so the next two, I gave you a note that talked about when you see fractions, what to do. Okay. All right, so when you see fractions, don't freak out. They're no big deal, but they're ugly. What we want to do is clear them out. We want to get rid of them. Okay. So when you see fractions, what you want to do is circle the denominators that you see. So here I see a 2 and a 4. And what you want to do is pick a common denominator. You want to say, what number will 2 and 4 both go into? I can't use 2 because 2 goes into 2, but 4 doesn't go into 2. But you could use 4, you could use 8, you could use 12, you could use any number that 2 and 4 go into. I'm going to use 4. Now, you have to multiply every term, even that 5, by the common denominator. You have to be fair. Okay, so whatever you put in the air, everybody gets it. Alright, so let's cancel out now. You say, how many times does 2 go into 4? It goes 2 times. And how many times does 4 go into 4? It goes 1 time. Alright, so if you were to multiply, you've got 2 times x, and you got 3x times 1, and then 5 times 4. So you multiply what you have left across the top. And now, that's so much prettier, okay? Clear the fractions and when you see them, and you'll get a better looking problem. And so now, no like terms, so I want x's on the left, so I'm going to subtract that. So I get a -x equals just a 20 over here. And you're not done until the x is completely by itself with a positive 1 in front. We've got a -1 here, so I'm going to divide both sides by -1. So x would be a -20. Okay. All right, now this one, let me copy it over just so I can see it a little bit better. All right, the big difference in this problem and the one that we just did was how many terms were in the numerator. Anytime you got those two terms, do me a favor and stick in parentheses so you don't get messed up. But everything works the same, okay? Circle the denominators that you see. We got 3 of them this time, 5, 2, and 3. And pick a common denominator. So what number would 5, 2, and 3 all go into? 30. So everybody gets a 30. Okay. All right, so let's cancel out. 5 goes into 30 6 times. 2 goes into 30 15 times. And 3 goes into 30 10 times. Okay. So if I multiply these two, 3x times 6, I get 18x. Right now, you're going to have to distribute that 15. Don't distribute from the air. Write it out and say, all right, I'm going to distribute that 15 and I'm going to distribute that 10. And if you do it that way, then you'll realize it's not a positive 15 that you're distributing. It's a -15 because of that sign. So if you'll write it out and not do it from the air, then you won't make a mistake. Okay. All right, so let's distribute that -15. So -15 times x is -15x, and -15 times -3 is +45. And if I distribute the 10 over here, I get 10 times x and 10 times 2. Alright, so I get 10x plus 20. Clean it up. Like terms. What is 18x minus 15x? It would be 3x. And then we're ready to move. So I'm going to subtract the 10x to get it on the left. I'm left with a -7x. And then I'm going to move my constants. I'm going to subtract the 45, and I hope I don't run out of room. So -7x equals, what is that, a -25? And then the last step is to divide both sides by that -7. All right, so what happens with the two negative signs? They're going to cancel. And you can't reduce 25 over 7, so just leave it as 25 over 7. All right, I put 2 more examples at the end, so let's do those last 2 really quick. These are just 2 special cases. You rarely see them. I just wanted you to be aware that they exist. Let me copy this one out here so I have room to work it. All right, what happens funny in this one? Let's see. All right, so first thing I would do is distribute the 3. and then I get 3x plus 6, and I get 7 plus 3x. And so the minute that I subtract the 3x and move it, what happens? What is 3x minus 3x? It's nothing. So the only thing left over here is 6, and the only thing left over here is 7. So you have a special case when your x ends up disappearing, okay? And so when it disappears, you want to get down to the end and you want to ask yourself, is this true or is this false? Okay, well, is 6 equal to 7? Okay, well, it's false. So if you get a false answer, a false statement, then your answer is no solution. You can either write no solution, or you can give this symbol for no solution, which is the empty set, that 0 with that slash through it. Okay. So that's what you do if it's false. Now let's look at this other one. That's what we do if it's true. So here I would leave this alone, but let's distribute that 7. So we would get 7x plus 7 minus 3x. And if I cleaned it up, my like terms here are 7x and minus 3x, so I get 4x plus 7. So you might notice it here that it's the same thing, but even if you didn't and you started subtracting your x's, okay, well again the x disappears because 4x minus 4x is nothing, and you get 7 equals 7. So when your x disappears, you say, is it true or false? Well, this one is true. So if it's true, you write all real numbers. Every answer is going to work. So you can either write all real numbers, or you can give the symbol, which is the capital R with that double slash, for all real numbers. Okay. All right, so go try your math up.